Good morning, all. In this class, we'll study about Claisen reaction. What is Claisen reaction? It is also called Claisen condensation reaction. It is also known as Claisen ester condensation because 2 moles of ester is involved in this condensation reaction. Please remember, in Claisen condensation, ester molecule is involved. Okay, let us see two examples here. 2 moles of ester, see 2 moles of ester, 2 moles of methyl acetate with the alpha hydrogen, in the presence of sodium alkoxide condense to give beta keto ester, because this is alpha with respect to this functional group beta keto ester. The second one is 1 mole of ester. See, at least 1 mole of ester condense with the acetone ketone with the alpha hydrogen atom. This is alpha hydrogen atom. This is the requirement. Okay, alpha hydrogen atom should be present for Claisen ester condensation reaction. So it gives beta diketones. Methyl acetate condensed with the acetone in the presence of sodium alkoxide or sodamide or NaNH2 or hydride to give beta diketones. So there are 3 cases. 1, 2 moles of same ester. See, 2 moles of same methyl acetate with alpha hydrogen. This is with respect to this alpha hydrogen to give beta keto ester. Okay, or 1 molecule of 1 ester condensed with the different ester. See, this is 1 methyl acetate, for example. You can take ethyl acetate here, ethyl acetate, okay, or ethyl ethanoate. At least 1 ester with the alpha hydrogen atom, please remember, okay, to give beta keto ester. For example, in this case, methyl acetate, 2 moles of methyl acetate condensed in the presence of sodium alkoxide or sodamide NaNH2 or hydride to give methyl acetoacetate or beta keto ester, because this is with respect to this is alpha position and beta, therefore beta keto group, this is keto group, beta keto ester. The third case, the third possibility is 1 molecule of ester condensed with the ketone with the alpha hydrogen. See, in this case, for example, methyl acetate condensed with the acetone with the alpha hydrogen in the presence of sodium alkoxide or NaNH2 hydride to give beta diketones. You see here there are ketone. This is alpha, beta, there are 2 ketones functional group. So it is called beta diketones. Let us study the mechanism of Claisen ester condensation reaction. This is a powerful base, sodium alkoxide ion. It abstracts a proton, alpha proton especially, to give carbon ion, an intermediate, unstable intermediate, and because H plus is abstracted, there are 2 electrons here, therefore there are 2 electrons with negative sign. H plus is gone, therefore negative carbon ion is produced. This is this 2 electron goes here, this is resonance stabilized. Okay, this intermediate attacks the electrophilic carbon to give the adduct, okay, and then it goes here. This is between carbon and oxygen, oxygen is more electronegative because it pulls the electron pair towards itself. It is delta minus. It is it has partial negative charge. It has partial positive charge. Therefore, it attacks carbanion attacks this electrophilic carbon to give the adduct. And this, and then further it loses OH3 to give beta ketone ester. In the case of ketone, in the case of one molecule of ester with one molecule of ketone with the, so ketone forms this carbanion. Ketone forms the carbanion because the ester, in the ester there should be leaving group. OCH3 is the leaving group here. Let us compare glycine ester condensation reaction with the aldol condensation reaction so that you will not confuse, you will remember very clearly. They are in aldol condensation, two molecules, 2 moles of acetaldehyde condense to give 2 moles of acetaldehyde condense to give aldol, okay, 2-butanol. This takes place in the presence of dilute NaOH. This takes place in the presence of dilute NaOH. So this is the simplest representation of reaction. We will study the mechanism. 2 moles of aldehyde with the alpha hydrogen atom condense to give alpha beta unsaturated carbonyl compound, because this is alpha, this is beta. So alpha beta unsaturated carbonyl compound, or one molecule of one aldehyde and one molecule of another aldehyde with the alpha hydrogen atom, called cross aldol condensation. We will study further. In this case, let us just compare the mechanism, the reactions, so that in ester condensation, in glycine reaction, 2 moles of ester condense, whereas in aldol condensation 2 moles of aldehyde condense with the alpha hydrogen atom. Let us see the mechanism. The mechanism is very similar. That's why I have shown here, so that you won't forget. In this case, OH minus is used, whereas in glycine reaction, sodium hydroxide cannot be used. Why? This is one of the competitive exam question. Because sodium hydroxide hydrolyzes methyl acetate to give acetate and methyl alcohol. Therefore, we cannot use dilute NaOH or dilute HCl. So, a powerful base, sodium alkoxide, sodamide, are used to abstract the alpha proton. Okay. So, in this case, OH minus ion abstracts a proton, alpha hydrogen alpha proton, to form the carbanion. This carbanion, again 2 electrons is there, is delocalized over oxygen. This forms enol. If you have H, then OH, enol. So this is enolate ion. This enolate ion then attacks this carbon to form this adduct, and this on acidification in the presence of dilute sulfuric acid or dilute HCl gives 3-hydroxybutanol. 3-hydroxybutanol. This undergoes elimination of water molecule on heating to give 2-butanol. 2-butanol, because 2-butanol. This is alpha beta unsaturated carbonyl compound. So if you compare and study, you will not forget, because the mechanisms are very similar. The next class we will study Claisen-Smith reaction. It is different, so that you will not forget, you will not confuse with one another. Thank you again for watching.